Morning, Year 10, and welcome back. We're moving on to a new unit, which is waves. I've attached the rag sheet for waves to this PowerPoint so that you have got it. It's really important that we make sure that we understand this. The learning outcomes are common to both the higher and the foundation. All that will be slightly different for the higher is the extension of how to use the equations that support this. Okay, so first of all, today we're looking at the nature of waves and the different types of waves and where we would find them. So this can be found in the Caboodle textbook, and we're starting on page 136 and 137. Now, if you are finding the PowerPoint too difficult to follow, please do log into Caboodle, and if you don't have your Caboodle login, ask one of us and we will help you. Mrs. Corbett has them all, or email me, or Mrs. Walker, or Mrs. Callis, and we will make sure that you get your Caboodle login. So here is the rag sheet. Now, just like all the other rag sheets that we've done, we're doing the first column, okay, and we are saying whether we are red, amber, green, to start with for each of these. Okay, so this is attached as a separate attachment, so you can print it off. Otherwise, just maybe do it on screen and save it. Okay, so this is going to require a lot of you thinking way back to year 7 when you were small, young, fresh-faced. Okay, and I want you to think about how many different types of waves you can think of. First of all, we start with sound waves, and I'm pretty sure that's what most of you would have thought of straight away. Then we've got light waves, water waves, Mexican waves, and seismic waves. Okay, they're the ones that cause earthquakes. And how would you describe these waves scientifically? Think about it. You need to know these two key terms, so I do suggest that you write them down. Mechanical, they need to move through a medium or substance, and that is sound, water, Mexican, and seismic waves are all mechanical waves. Whereas electromagnetic waves are created by electric and magnetic fields, okay, and these are light, X-rays, microwaves, and electromagnetic waves. So copy those two down. So wave categories. All types of mechanical and electrical waves can be split into two different types of wave, and we need to know the difference between them and how to describe them. You've already thought about these terms in year 7 and 8, and we want you to remember them, and we're going to give you 2 pictures to give you a clue. Yes, you're looking at those going, yeah, I think about those, I can remember them roughly, but what's so special about them? So the first one, you'll notice that the particle motion moves up and down as well as to the right, okay, and we notice that they are transverse. Now, the way that I remember it is that I always intersect the particle motion and the wave motion to make a little T, whereas the longitudinal wave, the particle motion and the wave motion always happen on the same axis. Okay, so there is nothing on the horizontal, there's nothing on the vertical, it's all happening on the horizontal. And again, with the longitudinal wave, I could put an L between those, and that would make my longitudinal. So try this at home, okay? So make sure, first of all, that you're clear. You're not doing this in your front room with all your mum's best china, or in your sister's bedroom, okay? And you can either use a piece of rope, a slinky spring, ribbon, or even a sock, okay? And it'd be more help if you get someone to help you. Tie the fabric or the sock to the centre of your rope or slinky string, and then you're going to ask the other person at the other end to tighten the door handle or somewhere that can't work its way free easily, and you're going to hold the other end yourself, and don't let go because it will be dangerous. Watch the tied fabric in the centre as you move it up and down. What happens? How would you describe that? So here is somebody doing it in a lab, not as exciting, and the wave is created that went up and down along the rope, but the fabric stayed in the same position. And we know that this type of wave is a transverse wave. We often see this on YouTube with ducks on water. So for argument's sake, the duck moves up and down, but he doesn't move along with the motion of the wave. Now we're going to observe this again. we're still doing the same. We're tying our fabric on, we're tying it to the door, and this time you're going to push and pull the end of a slinky slowly and see what happens. And what you do see is this. You see the energy transferred horizontally through the spring. However, you see no particle motion up and down. So there's the definition of a longitudinal wave. So in a transverse wave, the wave moves at 90 degrees, and the word that they really want you to use, okay, those geeks at the exam board, is perpendicular to the direction the energy is travelling in, okay? If you don't write the word perpendicular, they do really want at 90 degrees. Whereas there is also this idea that whereas longitudinal waves can usually fall in 1 to 2 types of wave, transverse can be mechanical or electromagnetic. Okay, and the examples of transverse waves are water waves, electromagnetic waves, which include light. You need to learn the definition of at least 2 examples. Oscillations of transverse waves are perpendicular to the direction in which the wave transfers energy. Okay. We also need to think about how we would describe a complete wave. Longitudinal waves are made up of areas of compression, so we can see those quite clearly on our graph over here. And here, they're my areas of compression where it appears darker. And then we have areas where the spring pulls further apart, and we call these rare refractions. And on the exam, there are 20 to 30 words that you have to spell correctly. And because rare refractions can be like similar to reflections and refractions, they are expecting you to spell these ones correctly. The particles move backwards and forwards, but always return to the original position. So they're not transferred, okay? And the movement is parallel to the direction that the wave is travelling in. Longitudinal waves are mechanical waves, okay? And longitudinal waves are sound waves and seismic waves. The oscillations of a longitudinal wave are parallel to the direction in which the wave transfers energy. So, remember, particles in a wave move up and down and backwards and forwards only. It is energy, not the particles. Move from one place to another. Think of a sailing boat out at sea. On a calm day with no wind, it just bobs up and down. It stays in the same location. The water waves are transverse, so the particles are moving perpendicular while the energy moves forward. This is why the boat remains in the same location. Now, it's only with the application of wind acting as a force on the sail that we actually see the boat move. Okay, so just let's check what we understand from today's lessons. Pause the slide now and ensure that you can answer the following 7 questions. So number 1, oscillations are parallel to the energy transfer in a longitudinal wave and perpendicular to the energy transfer in a transverse wave. Sound waves and seismic P waves are good examples of longitudinal waves. Transverse waves that you've learned about today: water waves, electromagnetic waves, including light and microwaves. What is the difference between a mechanical and electromagnetic waves? Okay, and we need to talk about the fact that mechanical waves need matter, whereas electromagnetic waves don't. Longitudinal because they require vibrating particles to form oscillation. Not all transverse waves have matter. Electromagnetic waves do not have matter. What is the definition of a transverse wave? Oscillations of a transverse wave are perpendicular to the direction in which it transfers energy. What is the definition of a longitudinal wave? The oscillations of the wave are parallel to the direction in which the wave transfers energy. Now, these are the key points from today's lesson. I suggest you write them down. Today's lesson will be assessed through a spelling test. Exciting stuff. Speak to you soon. Bye.